Hello everybody, this is Professor Jing, and today I'm going to talk about Introduction to Biostatistics, and this is going to be a brief introductory lecture to biostatistics. And let's begin. Here is the learning objectives of the chapter. By the end of the lecture, you will be able to define statistics and biostatistics, and also be able to discuss the core functions as well as the 10 essential services of public health. You will be also able to describe the role and value of biostatistics in public health, and be also listed the contributions of following statisticians, including Adolphe Quetelet, Francis Galton, Carl Pearson, and Carl Fisher. And lastly, you will be also able to describe the different types of variables and measurement scales. Since biostatistics is a portmanteau word made from biology and statistics, we need to know what statistic is before we talk about it. Statistics is defined as the art of science of making decisions in the face of uncertainty, and when it applied to the field of biology, life, and health science, is called biostatistics. Biostatistics is a scientific area that deals with development and application of most appropriate methods for data collection, presentation, analysis, and interpretation of the result, and making decisions on the basis of such analysis. Over the years, statistics grew via extending its application in biological fields. A few prominent scientists in biostatistics are Adolphe Quetelet, Francis Galton, Carl Pearson, and Carl Fisher. Some of the names should sound familiar to you if you have taken any statistics course in the past. Adolphe Quetelet was born in 1797. He died in 1874. He was a Belgian scientist. One of his great contributions is development of BMI scale, which is still widely used today. He suffered from apoplexy, which negatively affected his career. Galton studied the inheritance of intellectual characteristics among human beings. Based on the quantitative study of prominent individuals and their family trees, he concluded that the intellectual ability was inherited in much the same way as the physical traits. And later, he published his finding in Hereditary Genius in 1869. Although Galton made contributions to many fields of knowledge, eugenics remained his fundamental interest, and he devoted the latter part of his life chiefly to propagating the idea of improving the physical and mental makeup of human species by selective parenthood. He also introduced the use of questionnaire to collecting data. He is known as the father of biostatistics. Another person that we need to talk about is Carl Pearson. He was a protege of Francis Galton. He founded the first university statistics department in 1911 at University College London. In addition, he developed a very important concept of correlation, which comes under category of bivariance analysis. An interesting fact about him is that he studied law but never practiced as a lawyer. Ronald A. Fisher was a British statistician. He was known as the father of modern statistics and experimental design. The famous ANOVA was developed by him. We will talk about ANOVA in the second half of this semester. ANOVA stands for Analysis of Variance. One way ANOVA is typically used for is to determine whether there is statistically significance between the mean of 3 or more independent groups. Let's review the core functions of public health and its 10 essential services. Then we will talk about the role of biostatistics in public health. There are 3 core functions of public health, and the 10 essential public health services provide a working definition of public health and the guiding frameworks for the responsibilities of local public health systems. All public or community health responsibilities, whether conducted by a local public health department or another organization within the community, can be categorized into one of the services. These following 10 essential services serve as the framework to the local health system assessment we're conducting. Monitor health status to identify community health problems. Diagnose and investigate health problems and health hazards in the community. Inform, educate, and empower people about health issues. Mobilize community partners to identify and solve health problems. Develop policy and plans that support individual and community health efforts. Enforce law and regulation that protects health and ensure safety. Link people to needed personal health services and assure the provision of health care when otherwise unavailable. Assure a competent public health and personal health care workforce. Evaluate effectiveness, accessibility, quality of personal and population-based health services. Research for new insights and innovative solutions to health problems. Biostatistician plays a very important role in public health assessment. They need to decide which information to gather. Once this is done, they need to find the pattern in the collected data, make the best summary description of the population, and associate problems. Sometimes it is necessary to design general survey of population needs so that we can understand their health problems. They also need to assist scientists to estimate the extent of health problems and the associated risk factors. To assist with development of public health policy, statisticians develop mathematical tools to measure health problems, prioritize problems, quantify relationship of risk factors with disease, predict the effect of policy changes, and estimate the cost, including monetary, undesirable side effect of preventive and curative measures. Biostatistician plays a very important role in assurance. They use sampling and estimation method to study the factor related to the compliance and outcomes, decide if improvement is due to compliance or something else. They also take into account possible inaccuracy in responses and measurements, both intentionally and unintentionally. Now let's switch gears to some basic concepts of biostatistics that you need to know. In public health, we search for suitable data to serve as the raw material to answer any questions. Such data are usually available from one or more of the following sources. Routinely kept records. You probably can come up with a lot of examples of routinely kept records. Hospital admission, discharge records, child immunization records, birth, death records. When the needs for data arise, you should look them first among routinely kept records. Surveys. If the data needed to answer a question are not available from routinely kept record, then we needed to conduct a survey to obtain the information. Experiments. Another source of data is from experiments. For example, a group of doctors wish to know which several drugs is best for controlling blood sugar. They may conduct an experiment in which different drugs are given to the patients. Subsequent evaluation of the effect on the blood sugar will enable the doctor to decide which drug is more effective. External sources. The data we need already exists in the form of published reports, commercially available data banks, or research literature. In other words, we can find that someone else has already asked the same questions, and the answer obtained may be applicable to our present situation. Remember what the goal of biostatistics is? We want to make the statement about the population based on the sample. Sample is your data. The population is the large entity that contains everything that you want to make a conclusion for. So if you're talking about childhood obesity in the US, your population will consist of all children living in the US. Now you have to sample if you want to study that, because you can't possibly go get a sample of all children in the US. So we need to sample a small portion. The diagram I have on the slide shows how statistics works. So you have a population. That is the largest entity of observation that you could collect. From there, you get a small subset of sample from it. And you apply some type of sampling techniques, such as random sampling or conventional sampling. Then once you get the sample, you can characterize that sample using descriptive statistics. Then you can use the inferential techniques to that sample to infer a conclusion about the population. That is when you do a hypothesis testing, when you calculate the p-value, confidence intervals to make a conclusion about your population, not only your sample. The rationale is that if your sample is representative of your population, then whatever conclusion you make about the sample should carry through the population itself. So within the process above, we usually do two things. Summarize the data numerically and graphically using descriptive statistics and graphs, usually known as descriptive statistics. After that, we try to make statements about some of the features of population after analyze the data. It is called inferential statistics. We have various methods and techniques that exist for both, but choosing the appropriate method depends on the type of variable analyzed and what type of information do we get from the variable, such as what type of data do we have. That is the reason there is no one that fits all statistical data plan, because it is all data driven or data dependent. Depending on what type of variables information that you have collected, you have to use different methods to analyze it. As we observe a characteristic, we find that it takes on different values in different persons, places, or things. We label the characteristics a variable. A quantitative variable is one that can be measured in the usual sense. We can, for example, obtain measurements on the height of adult males, the weight of preschool children, and the age of patients seen in a dental clinic. Measurements made on quantitative variables convey information regarding amount. However, some characteristics are not capable of being measured in the sense that height, weight, and age are measured. Many characteristics can be categorized only as, for example, when an ill person is giving a medical diagnosis, a person is designated as belonging to an ethnic group. In such cases, measuring consists of categorizing. We refer to variables of this kind as qualitative variables. Measurements made on qualitative variables convey information regarding an attribute. Let's talk a little bit about measurement skills as it goes to what type of analysis is appropriate. By measurement skill, we mean the level of measurements. They are a classification that describes the nature of information within the value assigned to variables. We have 4 levels of increasing level of information: nominal, ordinal, interval, and ratio, where ratio scale carries most amount of information. Nominal. Values have no inherent order. Value only used to distinguish categories. For example, sex, race or ethnicity, female, male. There are 2 categories, but there is no order. Ordinal. Values are ranked to give an order, but the level of difference between the rank is not consistent. For example, a survey question where answers are bad, fair, good. Here good is better than fair, but there is no value in between. It does not indicate how much better. More importantly, they are relative terms. Your bad may be my fair may be his good. It depends on who's answering this question. Moving up to the scale, we have interval scale. They are usually continuous variables. Distance between values are equally spaced to indicate the level of difference in ranks. What does it mean? Remember, for ordinal scale, there is no set distance between bad and fair. If you're talking about temperature, 1 degree Fahrenheit is always 1 degree Fahrenheit. Whether you're talking about 50 and 51 degree or 90 and 91 degree, because 1 degree is always 1 degree. This has more information than the ordinal scale where you have order, but you don't have a distance. The thing that distinguishes interval scale from ratio scale is the choice of arbitrary 0. 0 degrees Celsius and 0 degree Fahrenheit are 2 completely different temperatures. They are both 0. In a sense of 0 is arbitrary, so that is why temperature, or the variable that measures temperature, is on an interval scale. If you want more information, you should go to a ratio scale. A ratio scale is a continuous variable. It is equally spaced interval. but there is an absolute zero. So zero, no matter what measurement you're talking about, it is on a ratio scale. It means the same thing. For example, if you are measuring your height in inches, feet, centimeter, or whatever, 0 is 0. 1 is different from all those measurements, but 0 means the same. In the sense that height has absolute 0 point, then height will be on a ratio scale. Practically speaking, it may not be important to distinguish between interval scale and ratio scale for analysis purpose, but I'm pointing out that there is a difference. Similar to ordinal and nominal, you may analyze them in the same way, but there is a difference between these two scales. An important note is variable with ratio scale is not the same as a ratio. The latter is simply relationship between two numbers. For example, odds ratio is the ratio of two odds, which is a ratio variable. However, a variable on a ratio scale indicates the level of A information in a variable.